Waves and optics. They're pretty simple things to understand. Now, I keep getting complained over because I have like really long intros, so I'm just gonna cut this short and go straight to the chase now. A wave and optics are pretty simple things to digest. Now, obviously, waves are very simple to understand. Now, a wave is just a disturbance, as you can see portrayed by the phantom, as it's moving throughout the space. A wave is just a disturbance moving through space. That is it at its most simple core, and well, I don't think I really need to elaborate on this one. Waves can be considered in two different types. First, I'm going to show is a mechanical wave. Now, a mechanical wave, it's the wave that's passed through using a medium. Now, mechanical waves, the difference, well, what even is a medium? A medium is just, well, a physical object that they can use to pass through something. Like clapping your hands or pressing on a step, pressing on a pressure plate. Now, saying that my force of pulling into this causes the medium, which is the redstone, which causes the end result, which is it playing a note. Like this. See? Now, an electromagnetic wave is pretty different. As you can see portrayed through this tunnel, I forgot that fences can actually pass through these. So I'm just going to remove them real quick. Now, a mechanical wave, it's somewhat the same principles, but also somewhat different. Now, no, sorry. What am I doing? An electromagnetic wave, it's still a wave, but like it's all about how they move. Now, electromagnetic waves can move through these things called vacuums. Vacuums, they're just like a place without any sort of mass and any sort of matter. Like, and the way that they can move through these is because they self-propagate. Well, basically, like they spread themselves through the area. So it's like pretend like instead of me having like the force of throwing the snowball just spreading itself through, like how bacteria multiply, but like they suck each other and like they keep going through. So like that. My aim's actually trash. Wait. I'm getting rid of the top part. Wait, what is for my? Guessing just not thrown. I feel I have to get an arrow for this. I don't want. Oh, team taking in one take. I'm a lazy bum. What? Wait, what? Yeah. So, let's just pretend that worked. Now, no, whatever. So pretend that worked. Now, that would lead to an ending result, which is this turning on. Now, optics, however, it's a branch of studying light. Now, light, it's like called, I think it's a dual wave duality. What it means is that it works both as a particle and a wave. Now, this can also be found in electrons, protons, and other sorts of subatomic particles, but in optics, you have, well, four, but I'll cover three of the main things. Reflection, which we all know about, staring at something it stares back at you because the light's bouncing off it into another thing, right? Basically, that's how a mirror works. Diffraction, where like, refraction first, which is how light bends when it enters like a liquid. And well, it normally works way better when it's dark, so I'll just set it to night real quick. So as you can see, what should happen is that like when you pull into this thing, yeah, let's turn it back out. So what happens is that like the light it kind of pulls forth and like it bends instead of like turning and torching in like normal ways. Diffraction, however, is the same thing as light bending, but unlike when it's through like going to water, it's when it goes to an object. So like let's say there's torches here, that is the object. So like my light, instead of like going straight through, it'll like curve around and curve back through. There's like a really deep understanding to this, but I don't really cover that deep because like there's one of those like you need cramp for a test or some crap. Oh no, okay. So hope you enjoyed the video. Leave a like, I don't know, subscribe if you want to, and good week.